Hello everyone. Today Huapa is gonna explain something that I don't quite understand yet, but I know that it has something to do with the backend.
Yes. Hi everyone. Yeah, I'm gonna explain shortly how our system works in general level, including the software and some of the server issues. So, we call it in general future full stack. And everything starts from a happy user. We have iPad here, and we have a happy user using the iPad. He's here. Here's our application, presses button, and a request shoots off to our backend system. I draw a few more of these just to make it more believable. First thing that the request will hit is a load balancer. We use Amazon's EC2 server systems, and we also use their load balancer, which is, for such a small company, quite easy to use. It's very easy to configure and serves our purposes fine. In general terms, this is just called load balancer. What it does is that it takes the request coming from the iPad or the application and redistributes it to a number of servers that actually do the logic, the hard thinking, what kind of seeds to recommend next and what content to recommend next. So, those servers come beneath the load balancer. So this layer we call front. And here inside we have a small layer of hangings that is simply taking the request and parsing very simple things to pass off to the next layer, which is a Ruby interpreter running the code underneath a thin, Ruby thin stack. So here we have the difficult logic layer, and at some later time our polished magician Woztek will explain a little bit more details about this layer. So here's our Woztek. So he'll make the magic happen here. Alright. The logic layer will use data storage that is commonly called just database underneath. The amount of data that we have to do the recommendations and content deliveries is so large that none of these small servers handling the logic can hold the whole data, so the data is handled separately on a separate servers. And they will be here. So this layer we in general call database, and for our case, as a database layer we use Cassandra. Cassandra is a very easily scalable system that handles internally how the data is distributed among the different servers within the database layer. And thus, again, we have a nice benefit of reducing the amount of time to configure the scaling part of the database system. Requesting the data from databases can be sometimes how do I say, it's a large amount of requests, and sometimes the speed is not good enough for just plain databases, and very often we need to get exactly the same data many times in a row. So for this kind of frequently needed data, we want to have a faster access to this data, and this layer is called caching layer. So that comes between the database layer and the logic layer. So the part of the data comes very quickly from the cache, and a little bit less frequently used data comes then from the database layer. So basically they request things from Memcached, and from Cassandra. And Memcached basically gets some of their data from Cassandra layer. So this layer was called cache layer. So this is the basic infrastructure for everything that you see on real time in the application. Some non-real-time things for processing things which the user doesn't, where we don't have to let the user wait for the results. We have still further a separate server for asynchronous processing. We call it background processing. So here we have background processing. And there can be also several instances of this. And to control the background processing, we have one central background processing queue system that delivers the tasks to the background servers. And that uses Cassandra as well as these. Here in short, we have a feature full stack.